Welcome to my student. Now today's lectures we are going to discuss the topic chemical kinetics. In these topics we are going to learn various methods can be used for determining the order of reaction. Now first methods we have see integration method. In these methods the given reaction of the values of A, B, X and A minus X obtained from the experiment. Those values then can substituted in the corresponding rate expressions like first order, second order rate equations. The first and second order rate expression, the values of the rate constant can obtain are compared. Then corrected expression for the rate constant is the one that provides constant values of the rate constant. So those constant values, they will show which types of rate order of the reaction. Hence, expression can selected corresponding order is the order of reactions. It means depends on the which types of the values which are obtained as a constant values. So those constant values we are clearly shows that which types of order of reaction can be done. Next method, now we are going to learn the graphical methods. For a graphical method, similarly the values of A and X and A minus X, they are obtained by experimentally, and then these values of A, X and A minus X obtain the graphs as like the first order reaction n is equal to 1. To obtain the graph as like the log of A upon A minus X versus times, and the second graph as like the log of A minus X versus time. So these two graphs, and in second order reactions there is a n is equal to 2. So X upon A minus X versus time, or 1 upon A minus X versus time. So these second order graphs and this is a first order graph. The pair of the graphs give the straight line will indicate the order of reaction. The graphical method is widely used to confirm order of reactions, but in general, if n is the order of reaction, the plot of 1 upon A minus X raised to n minus 1 versus time t, they also will be straight line having the slope is equal to n minus 1 into k, and intercept which obtained as 1 upon A raised to n minus 1. From the slope, the rate constant k can be determined by using the values of the plot of these values versus time, and with the slope is this. So from this slope we can calculate the order rate constant of the order of reaction. Next methods, now we have here half time method. For a reaction of order n, very small n, the half-life time depends on initial concentration of the reactants as per the relations as like the two different concentrations, that is at concentration A1 is equal to the T half bracket twice directly proportional to 1 upon A2 raised to n minus 1, and in second concentration they will be T half the T half 1 is inversely proportional to 1 upon A1 raised to n minus 1. From those graphs we can draw as like the x is equal to A2 by 2 versus t, or A by 2 versus t. For those initial concentration A1 and initial concentration A2, so those graphs will not show straight line. So T half for those concentrations which is obtained as this line. For combining about those two equations, then we get, so T half 1 upon T half 2 is equal to A2 raised to n minus 1 upon A1 raised to n minus 1. Taking the logarithm on both sides, we get the log of this T half 1 upon T half 2 is equal to log to the base 10 A2 raised to n minus 1 upon A1 raised to n minus 1. By taking the log on this side, therefore the equation becomes log of T half 1 upon T half 2 is equal to log of A2 upon A1 raised to n minus 1. And therefore, for those calculations, then we get, so n minus 1 into log to the base 10. You note the rule of logarithm. So this is a raised to n is equal to n into log of a. So this is the rule. So log of A2 upon A1 raised to n minus 1. Therefore, by taking the log this rule, n minus 1 into log of A2 upon A1. Then for those equations is equal to this, that is the log of T half 1 upon T half 2 is equal to n minus 1 into log to the base 10 A2 upon A1, and therefore this n minus 1 is equal to, this is n minus 1 is equal to, this value is into is here, is going to divide. Therefore n minus 1 is equal to log to the base 10 T half 1 upon T half 2 upon the log to the base 10 A2 upon A1. For those calculation for those terms, therefore n is equal to, right, n is the order of reaction, right, so n is equal to minus get plus, so n is equal to 1 plus, according to the rule of logarithm, that is a upon log of a upon b is equal to what is, so log of a minus log of b. Similarly, so this rule can apply is here. So log of T half 1 minus log of T half 2 upon the log of A2 minus log of A1. So the half times T half 1 and T half 2, they can determine from the graphs of x against t, right? This is T half 1 and T half 2, which is obtained from which, right, sorry, T half 1 and T half 2, these are obtained from the graphs like this. The values of the A2 by 2 and A1 by 2 will know. From those values we can find out the values of T half 1 and T half 2, and then the times required for completion of half of the reaction can be determined. T half 1, they will correspond to x1 and x1 is equal to a1 by 2, and t half 2 they will correspond to x2 is equal to a1 by 2. Alternating any convenient fraction of the initial concentrations, they may be chosen for the both sets and corresponding times can be determined. For example, the quarter reaction, 1/3 reaction, etc. So these reactions can be explained on the basis of those formula. Next methods we have see are here the differential methods. In this method, the rate of the reaction can be determined corresponding to two different initial concentrations like A1 and A2. By plotting the graph of x against time t, where x be the amount of reactants which has the reacted it or the amount of the product formed up to time t. But at the same time, the rate of the reaction can be determined for the two concentrations by drawing the target to the curve at a point determine its slope. So this x versus time t, we plot the graph, so they will show the slope is equal to dx by dt 2 and dx by dt 1. But you know that the equation rate is equal to this k into c raised to n. N will be the order of reaction and c is the concentration of the reactants. It means how much amount of reactants are converted to products or how much products is obtained from the reactants. And the rate at the time t can be written as like the rate is equal to dx by dt 1 is equal to k into c1 raised to n, and other initial concentrations rate is equal to dx by dt 2 is equal to k into c2 raised to n. By combining two equations, therefore dx by dt 1 upon dx by dt 2 is equal to c1 upon c2 raised to n. K will get cancels. By taking the logarithm on both sides, we get log of dx by dt 1 upon dx by dt 2 is equal to log of the c1 upon c2 raised to n. So according to rule of logarithm, so log of dx by dt 1 upon dx by dt 2 is equal to the n log of c1 upon c2 according to the rule of logarithm. So n log of c1 by c2, and therefore n is equal to, so how will you this interchange? N is equal to, these terms are here is a into, they will going to divide are here, therefore n is equal to log of dx by dt 1 upon dx by dt 2 is equal upon the log of c1 by c2, right? But next, this is a one step is missing which are understand. So this is the one step, log of dx by dt 1 upon dx by dt 2 upon the log of c1 by c2. Then according to rule of logarithm, then we can taking the log, so log of dx by dt 1 minus log of dx by dt 2 upon log of c1 minus log of c2, right? Then these values of dx by dt1 and dx by dt2, they obtain from the graph like this, right? This obtained from the graph. So x versus time t, so two different time t1 and t2, they will obtain two different slope, that is a one dx by dt 1 and dx by dt 2, right? Dx by dt 1 and dx by dt 2, so two different values obtained from the graphs, and put this value, in this equation are here, that is the slope, right? This is the slope, the value put it here, so put this value of slope 1 and slope 2 are here, and to calculate the order of reaction, and taking the concentration C1 and concentration C2, right? Now we have this second method for the determination of order of reactions. In this method, the rate of the reaction can be determined at the two different times during the course of reaction, at time t1 and at time t2. The rate of the reaction dx by dt is equal to k into a minus x raised to n, for the nth order, right? Nth order of reaction. So at time t1, dx by dt t1 is equal to k into a minus x1 raised to n. At time t2, dx by dt t2 is equal to k into a minus x2 raised to n. Combining those equations, we get, so dx by dt into t2, dx by dt into t2, this is a t1, this is t2, is equal to k will be cancelled, therefore a minus x1 upon a minus x2, n will be common, so raised to n. By taking the logarithm on both sides, we get the log of dx by dt t1 upon dx by dt t2 is equal to, according to rule of logarithm, n log of, right? N log of a minus x1 upon a minus x2. Therefore n is equal to, these values will be given to here, so one of the step is missing also there, so one step is, which is the log of dx by dt into t1 upon dx by dt into t2 upon the log of a minus x1 upon a minus x2. Then according to rule of logarithm, then what is the next step? So this is the next step, log of dx by dt into t1 minus the log of dx by dt into t2 upon log of a minus x1 minus log of a minus x2. Then these values of dx by dt t1 and dx by dt t2, they which is obtained from the graphs, according to the plotting the graphs x against t. So the value of x against time t, drawing the targets, the point we obtained at like t1 and t2, and the slope of the target gives the reaction. The slope is equal to dx by dt t1 and dx by dt t2. Put this value on this equation and we can calculate the values for the order of reactions, right? Okay, thank you.